Hi everybody. So in today's lecture, we are going to do air pollution part 1, and I'm going to quickly go through the highlights to try to fit it in, but you might want to pause the video, make sure you read the slides carefully, and you might want to take some notes as I hit sort of the main points. Okay, so first of all, I just want to review a few words. We've heard these when we talked about water pollution. So you can have mobile or stationary. Stationary, one spot, doesn't move. Remember point and non-point. So point is coming from an identifiable source. So you can tell it's coming from that smokestack versus non-point, which are more diffuse. All right, and then when we talk about air pollution, we're going to mention primary and secondary pollutants. Primary are what's emitted. So this is what the actual pollutant coming out of the smokestack is. Secondary pollutants are what happens when these primary pollutants then react with each other in the air or react with sunlight, and they form different chemicals, and those can be the secondary pollutants. All right, and we can also think about residence time. So some of these pollutants might not stay that long, so they only affect the immediate area, but others, think of carbon dioxide and our greenhouse gases, can have more of a global or long-lived effect. All right, and then here's a quote just to point out how important air pollution monitoring and reduction is, because it really does play a role with people's health. Okay, and here's just a graph showing some of the various symptoms of children in Mexico. So Mexico City has an historic problem with air pollution. And you can see mostly what we're going to talk about are respiratory symptoms for the most part. All right, in the U.S., the Clean Air Act of 1970 really set what we monitor and how we monitor it. And there have been additions to this over the years, but this was sort of the main act that set this up. And it basically set the EPA up to monitor both emissions of chemicals and then to monitor how much pollutants were in the air itself. It's up to the states to monitor, develop, implement, and enforce the regulations. And then they focus on 6 criteria pollutants, which we're going to go over in a minute. So just like we have water quality, we have air quality standards. And then in 1990, they added on a lot of additional chemicals that the EPA can set regulations on, as we realize that there are a lot of chemicals that people were just starting to identify and figure out that they caused problems. All right, so here are the 6 we're going to focus on. These are the 6 that the EPA monitors the emission of. So we have carbon monoxide, sulfur dioxide, nitrogen oxides, volatile organic compounds, particulate matter. So these are things that are a little bit bigger than this. These are like particles, but they're small enough that they can be suspended in the air. And then lead. And we talked about lead when we talked about water, so we'll briefly mention it here as well. All right, one thing I just wanted to point out is we're going to focus on human sources, but there are actually natural sources as well. So think about dust storms. Obviously, that's air pollution you're going to breathe in. Forest fires are releasing a lot of different ash and soot to the environment. Volcanoes, remember we talked about sulfur dioxide and how it can be actually get higher up in the atmosphere and form these aerosols. So it can actually cool the climate. So you may remember we talked about the year without a summer, which was 1816, because a volcano had erupted the previous year. But one thing you may want to see if you can do is some of these dust storms, fire, right? They can all be made worse by human actions. So we talked about that when we covered those. All right, so let's go through our pollutants. So carbon monoxide, CO, is formed from incomplete combustion of fossil fuels. All right, vehicles and engines. Consequence, what happens is CO combined to hemoglobin. So you might remember from biology that hemoglobin binds to oxygen. So that's how we get oxygen to our tissues. So if CO binds instead, then we have a problem. All right, most of the time outside, this isn't too much of an issue unless you already have an underlying condition where getting a little bit less oxygen is going to really matter. But indoors, it can become more concentrated And that's why you might, if you have natural gas as a heating source, you probably have a carbon monoxide detector, because if something goes wrong and it generates more CO, you want to be able to recognize that. All right, sulfur dioxide, so that's SO2. This is again from fossil fuel combustion, mostly coal. And it can react, so sulfur reacts with oxygen to form SO2, and then that may react to form other, notice our shortcut here is SOx, so this is just other types of sulfur oxides, okay? And we said that it also comes from volcanoes. Health, it can harm the respiratory system, increase asthma, and we'll talk about how it contributes to smog and acid rain as well. All right, here are NOxes. Again, this X is just shorthand because there's a couple different varieties, NO, NO2, nitrous oxide. This is also from emissions from cars, trucks, buses. It can aggravate respiratory diseases. And again, this also reacts to form ozone, which we'll talk about. And both of these are also harmful when inhaled due to effects on the respiratory system. All right, particulate matter. All right, and we discussed two different types based on size. So PM10 means it's 10 microns or less, and PM 2.5 is 2.5 micrometers or less. So these are the smaller ones. All right, and these are anything that's emitted that's going to form these particulates in the air. So dust, unpaved roads, fields, smokestacks, fires, okay? It can form various secondary pollutants that are formed from other primary pollutants that are released. The smallest ones pose the greatest risk to the health, because if you think about it, they're really small. We inhale them more deeply, and our lungs have more trouble getting rid of them. All right, volatile organic compounds. These are things that are emitted from a wide variety of industrial and household uses. So think of chemicals that smell. These are things that are volatile, right? So they actually go from liquid to gas quite readily. So gasoline, if you pump gas, you can smell the gasoline. That's because it's letting off those volatile organic compounds. Paint thinners do it, anything like that. So here's some examples. Natural sources, plants actually emit these as well. So the Blue Ridge Mountains were named from the blue haze that forms, and that's from these VOCs from plants. All right, lead, again, we talked about this being in water, but it also in the past was used as an additive in gasoline to make cars run more smoothly. And once in the 1980s, we started phasing this out, and then lead pollution in the atmosphere dropped. So this was really the main cause, was this leaded gasoline. And obviously we talked about what the effects of lead were when we talked about it in water pollution. All right, and here's an example of now monitoring of the air pollution. So this is actually the daily air quality index, and so they monitor it by color. So green and yellow are kind of okay. When you get orange and red, that's more dangerous. Here are the ones that they monitor. So there's really 6 here because this particle pollution is the 2 categories. All right, and then here, notice that they're monitoring ground level ozone. So what is ozone? That's the one we haven't talked about. So ozone is caused by pollutants that are emitted that we've already talked about that chemically react in the presence of sunlight to form ozone. So ozone is a secondary pollutant. All right, you might remember from chemistry, oxygen is normally diatomic, so it's normally O2. Ozone is O3, okay? And then it's really, again, a lot of respiratory problems. It can worsen bronchitis, emphysema, asthma, leading to increased medical care. And it's going to harm sensitive vegetation during the growing season. And because it forms in the presence of sunlight and heat, this is generally going to be worse in hot areas or during the summertime. All right, so here's our equation. This is what you probably want to really pay attention to. So here we got NOxes plus VOCs plus heat and sunlight gives you ozone. So here's the primary pollutants, right? Reacting in the presence of sunlight to give you the secondary pollutant, which is ozone. All right. Okay, so we've now covered sort of what they mainly monitor, but you've also heard of smog. So what is smog? There's actually two types of smog. There's industrial smog or gray air smog. And this is basically when you think of like coal-fired power plants or industrial plants that have those smokestacks going. So this is caused by a lot of sulfur compounds in the air that are going to form these sulfates. And they form this really sort of dense smog. Remember we talked about Donora, Pennsylvania and London having smog issues. We'll get back to that in a little bit. All right, but we also have photochemical smog. And this is smog that requires the light, photochemical, right? It's referred to as brown air smog. And this is what's going to produce that tropospheric ozone. That's the ozone we've been talking about. Remember, troposphere is where we are. And this is going to form on hot, sunny, windless days, and it peaks in mid-afternoon. So think about it. This is caused by cars, mostly, that are going to emit various nitrogen oxides, and VOCs. It reacts with the sun, and you get ozone, and you also get some other nitrogen dioxide. And these all form together to form that photochemical smog. And this is really bad in cities where there's a lot of urban population, a lot of cars in hot areas. So LA, famous for its smog. But in Baltimore, we also have like code red ozone days. So this also is generated in many urban areas. All right, here's photochemical smog over Mexico City. All right, and this is just taken from today's air quality index, which was good. Ozone is our primary pollutant at the moment, but nothing too bad is going on. All right. And this is just showing areas of the country where we're failing to attain the standards. Notice here, Southern California. So we talked about LA, urban area, lots of cars, right? That's going to be a problem. And these areas are more industrial if you think about it. So East Coast, Midwest. But if we look at these over time, so this is actually showing 1970 to 26. Look, they've almost all decreased, and lead really dropped. Lead had to have its own axis over here, note. All right. And notice the emissions dropped while all these other things went up. Population, vehicles. Why? Here's another graph that shows the same thing. So why is air pollution decreased? Well, remember, we talked about some of these technologies. So we have catalytic converters on our cars. And notice you have to take your car in to get the emissions tested. That's what they're testing, that your catalytic converter is operating correctly. SO2 permit trading. So that basically said we have a limit on what power plants can generate. If you're under that limit, you can sell off your excess permit. So it can be profitable to be a non-polluter. Remember baghouse filters, electrostatic precipitators, right? And then we got rid of leaded gas. You might want to pause this and look through this. This is showing a scrubber. All right, here's a catalytic converter. So notice the job is to take the pollutants and turn them into things that are not pollutants. And so there's various chemical reactions that are going on in your catalytic converter. Okay, so we've actually made it through, and I have a few sort of summary slides. And these are taken from actually the AP topics. So sources and effects of air pollution. Read through, do these all make sense? Okay, photochemical smog we talked about, and they pay a lot of attention to. Notice the timing, notice where it happens, how do we reduce it? All right, thermal inversions. We didn't talk about this here. You might want to go back and review. We talked about thermal inversions when we talked about the atmosphere. So that's when the pollution gets trapped. And that was that Donora smog incident and the Great London smog of 1952 were thermal inversions. All right, atmospheric CO2 and particulates. So there's a big fight going on in whether to classify carbon dioxide as a pollutant or not. Obviously it is, but the EPA is currently not regulating it. And then here are some ways we can reduce air pollutants. Okay? Hope you enjoyed it. Bye.